And we're live. Okay. I may have forgotten that I've streamed today, but it's all good. I'm here. Um, yeah. So this is day 98 of studying compilers every day until I land a compiler role. Um, I might have accidentally found out that I do in fact have a final on this upcoming Thursday and then an additional exam on Friday. So that's where most of my time outside of stream is going. And I might also cut the stream a little bit short for that reason as well. But yeah, last time I think we fixed everything that doesn't have to do with tree tiling. So everything in tree merging that was broken, and then like some other small changes here and there if I remember correctly. But that puts us in a really good spot now. All of the tree merging stuff is done and dusted, I think. It should all be correct at least, which is good. So all that we need to worry about now is, well, just tree tiling, which should be a fun time. Yeah. So I gave the spiel a couple days ago, so I'm gonna go through it really quickly. I'm not gonna go like too in depth, but we're working on instruction selection where we have a intermediate representation of our language. We've done a bunch of optimizations on it. So now the last general stretch of the compiler is just turning it into assembly. The first step in that is instruction selection, which we have our intermediate language, and then we have like assembly. They don't map one-to-one to each other. So we want to, I guess, we want to make trees of operations, and then we can then cover those trees with instructions that can hopefully let us produce as efficient of an instruction set as possible. So yeah. Here we are. So let's, I guess we could check git log. Yeah, there's just like some small stuff we had to fix, but for the most part, it was pretty smooth. So now if we make, and then we just run our tests real quick, it should all, yeah, it's all pretty good now. Yeah, so let's look closer at tree merging, or not merging, tree tiling. So we have, so the idea is we can like define a bunch of different tiles to, I guess turn these like tree nodes that we have into instructions, and some of them can span multiple nodes. That would be the ideal case, but right now we have to, I guess, we have a couple more things to worry about up until that point, such as like, I don't know, actually being able to cover the tree. So I think what we're going to start with is just a very minimal tree tiling. I don't really think we need this tile class. That seems a little bit extraneous now that I look at it. Yeah, so we have all these different nodes, and we can kind of just work through these one by one. Node is like the generic one, so we don't really need to do anything there. If we hit that point, then we shouldn't be hitting that point, rather. ASM node is trivial because we've already generated the assembly, so we can just vomit out the assembly that we generated there. I don't think there's really anything interesting to do with... Actually, no, there are some interesting things to do with registers and immediates. Well, immediate is a little bit silly because it's just a number. Register, we might have something as long as its child is not a null pointer. Yeah, I guess we could start with those. That's a pretty good spot. So immediate should be a no op. Register, we should just check if it's a... I guess the logic here is, or let me keep that one down here so you can see that on the stream. It's not covered. Yeah, let's look through here. So register has a name and a source. So yeah, okay. So as long as we have a source, we're Yeah, as long as we have a source, we can do like a move here, at least. We can generate a move instruction. Yeah, okay. So I guess we don't even need to like write this out explicitly. So we can do like, so we can do n, and we can get source. I guess we could do a guard clause instead. So if that doesn't exist, so if that's a null pointer, then we can just return. And that'll be the default case. Otherwise, we want to generate a move instruction. So we should probably look in LIR here. Or actually, we could steal some code from TreeGen, because we definitely have a move here. Yeah, something like this. Yeah. So I guess we can do this for now. We can define everything inside of that in a second. Yeah, so there's the move. And we want assembly. We want to push back, right? Yeah, we want to push back. Or we want to move it. We want to move the move. How about that? Okay. So now we shouldn't need to extend, I think. I'm fairly sure there's no instance where we need to extend. So we can definitely just like steal some of this, I think. So we have those. This should also just be that. I can do n. Got that cycle fixed with the tree copying a few days ago? Yes. I fixed pretty much everything that was, or at least everything I could find in TreeGen and tree merging. So, yeah. I think, I'm trying to remember what caused that seg fault. I'm trying to remember which seg fault it was to begin with. Oh, yeah. I think one of the causes, there were like two causes to it. One of them was that one of my optimizations earlier on was, it was eating up the entry block, which was causing issues. And then the other one, I don't remember off the top of my head. There was some like really, oh wait, no, I wasn't handling conditional branches where both branches pointed to the same node. That was causing a problem. So I handled those both, and those are resolved. Yeah, this should be, these shouldn't be quad word, double word actually. Yeah, so we can do that. Should probably switch these. Oh, we should visit the child. So we want and get source. We should probably, we should just put this in a temporary here. Oh, this is a putter. I should not. Yeah, we should just do that. If that's a null putter, then we can return. Yeah, okay. So we want source, accept. I'll make it accept this, I think. Or ref to this. Or, oh, that's what was wrong? Yeah, okay. Okay, so we can do that. Or actually, could we just visit this? Or visit source? Oh. I think this is like the correct way to do it. I don't care about speed right now. I'll worry about that later. So this gets us the source. No, this doesn't make sense. Huh. Actually, how do we generate tiles for this? I think a lot of the stuff will have to fall into N, actually. Yeah, because everything kind of breaks on the register, right? Like, there's not gonna be an instance where we just directly visit an op node, for instance. Like, that's kind of not possible. So then, yeah, okay. This is a little bit more complex than I initially thought it would be, which I guess makes a lot of sense, but still. What's good, Kubit? I don't think I've seen you here before. So welcome to the channel, I guess. Okay, we might have to do away with this visitor thing, actually. We might just have to like take an arbitrary tree, I guess. And this is where the tile structure comes back in, I think. Yeah, we might have to keep this here. Okay, we're gonna nuke all this. When should this return? What's good, JK Master? Welcome. So the broader project I'm working on is a compiler from C to x86-64. Most of it using modern compiler design techniques, I guess. The main focus is on the optimizer, but I still need to generate code to some capacity. So right now, that's the part I'm working on, or that referring to the code generation. Right now, I'm trying to map my optimizer language down to the assembly, which I can then do more stuff with later on. Well, this process is quite difficult. I have not gotten enough experience with this before, so there's a lot of work to do. We can get rid of that slash actually. Okay, let's make this not a visitor. Let's make this a tree tiler. Let's make a tree tiler class instead. This visitor doesn't really make sense because we're not going to be like visiting this node by node, I feel like. Because like all the top level nodes will either be like a register or like, I guess like a load maybe. Or no, it would be a register or a store pretty much, or an assembly node. So this sort of mapping doesn't really make sense. Okay. So let's get rid of this thing. Instead, let's do class tree tiler. And that should get us a little bit better mileage. Yeah, it turns out there's a lot of data structure design stuff that I need to do throughout this whole process. So I will be going back and forth very frequently on this. I don't know, I guess I should make this like, maybe I should like restructure some of this to just suck less. maybe I should just like, I should change the interface of these to just be more pipeline friendly. I feel like this is not very enjoyable, I guess, just looking at this right now. I guess that one's like fine to not be pipeline-y. I think, I guess maybe, I think I could probably just do like a tile function here. I guess this should, what should this return? I guess I could, do I just keep an internal buffer though? I feel like that might be better. It looks like I have like this, I guess we have this like get result thing there anyway, so we could probably just keep that sort of interface at least. Okay, I can't deduce the type from that. So I need a std list of, or wait, no, I can check somewhere else. I can check in the node, aha. Because our assembly node can do this. Okay. So that's our assembly. We should maybe just call this, yeah, we can call that assembly. And then we can also paste this here. Yeah, okay. And then we need like a void tile function. And then we should make this take, I guess, a node star maybe? Yeah. Yeah, this is a list of node. So we should, I guess, take, I guess the nodes don't really matter anymore at this point, so we can kind of just like, just take node star, right? Or tree, maybe? Yeah, that seems like a reasonable interface. And here, I guess we could also just do that for each tile. Unless we want to just like stick a bunch of lambdas in here. That sounds very untenable though. I guess if we're just like running it through a list, I don't think it's the end of the world if we just throw 30 lambdas inside tree tiler. Yeah, we can abstract this later. I think this is gonna be the reasonable way to start this at least. Yeah, we're gonna need to change this stuff real quick. This is the tree tiler. We do need to take the operand manager. Is this C or C++? The language that I'm trying to compile is C, but I'm writing the compiler in C++. So this should take operand manager ref. Right. Can I get rid of skipping that? I can. Okay, cool. Okay, so that's good. Yeah, so we don't have accept anymore. We have, let's rename this actually. This is not really visitor anymore. Merger, let's make this Tyler. Yeah, that's a little more descriptive. So we wanna tile tree get. And this is Tyler. Okay, I think that's everything here. We don't care about IOStream. We don't need node. That's really funny, actually. Yeah, we've abstracted so much out just with using auto. That's quite funny. Okay. So we can do that. That's all good. I guess now we can like implement the thing, I guess. So let's, for my sanity, I will put this. How do I want to organize these windows? Let's put the tree tiler stuff here. I guess nothing really interesting is cut off by my camera, so that's fine. Or I guess until I need another pane, I will do that. Okay. This is not gonna be fun to write. There's just gonna be so much happening. Hopefully it's hopefully it's fine. Let's make the constructor real quick. Oh, it's a ref. Whoops. And we also need to store that inside, actually. So let's paste that here. Yeah, that's a ref. That's good. I think. OM is OM. Alright. Simplest constructor I've written in a while, thank goodness. Okay, that's good. Get result should also be pretty straightforward, I think. Oh, what am I doing? This is not C#. We return assembly. Oh, wait, no. This should be a rested move assembly? Yeah, because that's unique pointers, so I'd have to move it. Okay, and that leaves us with the namesake function tile, which I'm not excited to implement today. It seems like a lot to do. I should probably define the tiles somewhere. Okay. So I guess we could like, I guess while I can't do like a one-to-one tiling with like each node, I guess what I could do is I could kind of you look at the existing nodes and sort of get an idea of like what instructions we need to tile here. I guess we could start by like just dynamic casting tree, because there's 3 types of nodes we can really take here. Yeah, it can either be an assembly node, in which case we just append. That's like the easiest case. It can be a register, in which case we have to do a lot of stuff, or it can be a store, in which case we only have to do some stuff. Yeah, okay. So I guess maybe I should just like abstract this into like a tile class. Yeah, that should be something I do, I think. I'll write it with lambdas for now, I guess. Yeah, let's do that. Dynamic cast to ASM node, star. Let's take tree. We can do this three more times. We need reg node, and then we need a store node. So those are kind of the only terminals we should be able to find, I think. Or reg node and store node are annoying. ASM node should be pretty straightforward. Yeah, so this is an assembly node. We want to do something there, and then return. I guess we can just like assembly. We can. What's the function again for this? It was. It's not quite append. Splice. That's what it was. We splice to the end, and then want to get assembly. Yeah, that's all we need to do for assembly node. That should be the easiest. I think what I will do, I will actually implement another node right now, which is just like a temporary node. Or not a node. We will add like a temporary instruction, which is just like tree to, we need to add a tree still. Yeah, we'll just do that for now. And then we can do this one more time. Okay. Yeah, let's add a temporary instruction. This will be really funny. We have like this whole virtual wrapper thing. That doesn't help us. Let's just like, yeah, fuck it. Let's add a to-do instruction. Let's do that real quick. I guess like, actually no, this doesn't even need to be temporary. This could just be the default case if we can't merge anything here. Yeah, let's try that out. So we want recognized or default. Oh wait. We don't really need a special constructor here. We should probably have an accept function. I think that's kind of all we need. This doesn't really need to hold any info. We could just give it the tree node actually. That could be an interesting way to handle this. That might also be overcooking, so maybe I won't do that. Let's make this unknown. So we can steal this. Do that. Yeah, we haven't implemented any visitors for this yet, so that's very lucky. I don't have to change anything yet. Yeah. Well, I need to throw in a quick accept function for this real quick. This should be instruction unknown. Okay, so we want. Should be make unique. Oh wow, I can't type. IQE. So we can do that. We don't need that. And then we can push this back. Or let's rename this so it's not ambiguous. Alright. Okay. Maybe I should add like a print for everything real quick. Yeah, that would be smart. Yeah, this needs a visitor. So I guess we can steal this pile here. Yeah, I've needed to implement this for a while anyway, so I think it's about time. This extends instruction visitor. I don't remember what my other visitors look like, so we're actually gonna look in the tree gen again for what we do about it. I think we just undefault these. Yeah, we just undefault these. Yeah. What's good, Niraj? Good to see you. The canonical #1 viewer of the channel. Okay. I guess we can just we can do this, and then I do need to go back to the other thing again real quick. It's tree gen, yeah. So we want to get result as well. That also reminds me, this should be a new line. Yeah, let's put this here actually, so I can see everything. Yeah, so that looks good. We want I don't think this needs the operand manager actually. I think we can just follow the putters. Stop by to say hi, off for the night. Good luck. Thank you, Bizadian. Yeah, have a wonderful evening. Isn't having 10 virtual functions gonna be slow, or is an exception? Well, there's not really a way around it here is the thing. Because the entire point here is to do dynamic dispatch. So it's kind of just I guess it's like a necessary evil, because the alternative is to, I guess, dynamic cast every time, which is probably slower than that. So it might just be doomed, I fear. Do I need the operand manager? What is the operand manager again? Oh god, I forgot about this file. Oh no. Ah, okay. Oh, I see. Okay. So this is just about creating operands. That doesn't matter to us then, I think, as long as it stays alive. So as long as it doesn't get dropped, I think it's fine. Yeah, okay. That's fine. So it's just the pool, I guess, is the way I'm thinking about it. So where's our other 2-string visitors that we have? I guess we even have one in here, right? Under node? Yeah. We have this thing. Can't use a template. I don't think you understand why I'm making these these different functions. I guess the thing is we want different behavior for each, class that we, I guess, have a visitor for. So a template would, I don't think a template would let us get that different behavior, nor would it allow us to call the distinct function at runtime, at least. Because what we want to avoid doing is we want to avoid just it calling the generic instruction one every time. Because or the 2-string function that lives in the existing, I guess, instruction class. So we have a list of instructions, so it will, I guess, use the function that lives in the instruction level cast, I guess. I'm explaining this very poorly, so let me know if it doesn't make sense. Thought we were doing the same thing? No, of course not. Yeah, we wanna print different things for different instructions. Yeah, I think this is all we need at the interface level. So I think we can just put this to the side and we can just throw this at this now, which does not bring me joy. Okay. Do we have a label instruction? We might need a label instruction. We might need a label instruction, actually. Wait, I swear we have a label instruction. Did I just forget to add it here? Yep, we do have a label instruction that I forgot about. Okay, great, wonderful. Let's paste that here. This is label. And then everything else is the same, right? So move, push, pop. We have compare, we have jump. We have cjump, we have call, ret. And then we have like the virtual pile, the non-real pile. Okay, cool. That also means I need to add this in here, right? Yeah. Or this should be label. L makes sense here. Let's make this an L. Where am I? I'm in here. Okay. So this should be L as well. Huh, that rhymed. Okay, let's implement the trivial stuff again. We need a private field. Oh boy. What the hell? Okay. First try. Yeah, I think result is correct here. So we can do that. Now we need all the visitors. Let's paste that. Let's make a macro here. Let's do that. We do that. And then we can do braces. We can repeat that across all of these. Okay. So you have this big wall of slush. Okay. We can fill that in a second. For now, I guess we can actually start filling in this function. Let's do toString visitor TSV, or yeah, so we can make that, and then Reichstein instructions. This should be a ref. Whoops. We want I to accept TSV, or a ref to TSV. Cannot cast? Oh. Whoops. There we go. So we can do that. Okay, so we can accept, and then we can just return TSV get result. Yeah, this toString is way more simple than all the other toStrings that we've done up to this point, I think, because we just have a list and we can just go through it. There's no other slush metadata to vomit out, I think. Yeah, okay, this seems reasonable enough. I guess, do I want to just like stick a new line after everything? I guess, what's the best way to do this? I guess we could just like... I guess unknown is probably the safest one to start with. Yeah, let's do that real quick. Or can I just do not result? Check for empty string. Yeah, okay. I should just do this. Let's just add a new line character to that. Or if it's not empty, then we should add a new line. Yeah, let's do that and call that a day. Virtual is a decorator. This is the first time I've ever actually used the decorator pattern in something, in like an actual project. So this is really funny to me. Yeah. So what do we do here? Let's make this like, I guess, how do we want to represent a virtual? Let's change this actually. So we can do that. And then huh. Okay, we might wanna get rid of this actually. If we're doing like recursive stuff, maybe. Actually, no, this is fine. We just have to, we'd have to be a little clever with this, I think. I think we could just append it with virtual. Or what's a comment in assembly? Is it just a... It's a semicolon? Or... Yeah. I know this had comments on it. I know for a fact. Registers, da-da-da. Okay, that doesn't help me. Oh, there we are, okay. So we can do this, I guess. Alright, we can do that, I think, for now. But we want to... We need a way to unwrap this, I guess, at least. Yeah, because this wraps an instruction. Oh, we're gonna need to write getters for... Oh, no. Okay, let's do... we can do this. We can do unique putter, get instruction, or ref, get instruction. Yeah, we're gonna need to do a lot of patchwork here. return. I see, do that. Oh, that actually works. Nice. We can get instruction. And then we can accept this. Yeah. So then that just adds this virtual text onto that, and that will be fine. Yeah, okay. There's probably a better way to represent this. Maybe I should use square braces here. Or this should be indent like that. Okay. I think we can stick this into all of these at least. Actually, let's just boilerplate this in by hand. Oh, that's not what I want to do. Okay, let's just do this by hand. Okay. I don't particularly feel like implementing all of this right now, so what we're gonna do is we're just gonna make this a to-do. Alright, this should be a ret. Should be a fee. This should be a call. Yeah, we'll just do that. Should be pop. Push. Maybe move, and then we can do like... Oh, label should not be hard. We can definitely do label. I will do label because that will give things a little bit of shape at least. Because I think I will go insane if I don't do label. We already have get name, so that's already half the battle for us, I think. Nothing else really has getters, so it's just label. That's pretty funny. Is it implemented though? It is implemented. Okay. So what does the indent look like on assembly? Let's open a Godbolt maybe. Let's get rid of that. Okay, well this has some ugly indenting. What is the back end here? Yeah, we're doing AT&T. Okay, well, this is quite ugly, but that's fine. What happens if I do that? That's really funny. It just does everything. So what indent level is this? Is this 8 space? Huh, okay. Well, I'm not gonna worry too much about that for now. This is all to do anyway. So we want L, and label is just the label, and then we want a colon at the end. Yeah. Let's replace to do. Let's replace everything there. Everything there with her. Yeah, let's do it like this. This will be let's do this, actually. That should be a little bit less awful to read. Or it absolutely will be just as bad to read, but it'll be a little bit less bad to read. Yeah, so let's do that. So that's our toString visitor. So we can print things now. Let's see what this prints. I'm very curious. It might not print anything remotely useful, but it'll be funny. Yeah, I'm quite stressed about my exam on Thursday. It's for deep learning, and we talked about transformers and none of it made sense, so I need to spend a lot of time studying that again. Let's give it like, that's a simple one, op, I think. Oh, cool. That's cool. Well, that kind of works, I guess. That kind of does work. Yeah, okay. What happens if I name this something that's like... Is this like forbidden? Or... Oh, okay. So that collision is fine. That's nice. That's good to know. So I don't need to worry about that there. Yeah, okay. This seems fine. We should probably format the labels a little bit less poorly. So if it's not empty, then we want to add a double new line. Yeah, so we want this to be double new line. Okay. Looks like we're not getting the unknown instructions anywhere here. So maybe we could give it like another test. Okay, well there's other things here. This is really fun to look at, I will say. Maybe I give it -0? Ah, there's the unknowns. Okay. So I guess it was just folding everything, which is pretty funny. Yeah, there's a lot of unknown there. Yeah, okay. Yeah, okay, that's really cool. Rumination on C++ or the C++ object model are 2 books. Yeah, I think I haven't seen those. I'll take your word for it. I'll add those to the general recommendation list, I think. Okay, let's commit some stuff real quick. Let's add LIR as a whole. Start LIR to string stuff. Bye, tile visitor, hello Tyler. Okay. Apologies if anyone in chat's name is Tyler, because this might get confusing very, very quickly. I promise I am not like saying your name. I am like this is so brain damaged. Apologies. Yeah, we're just gonna do this by hand. Anything but be fast. Okay. So that's good. What do we even do now? What the hell do we do now? I should probably spend a different stream just like implementing all this 2-string stuff, but that's not really my concern right now. I'm a Tyler in the sense that I've tiled whole bathrooms/showers before and some floors. That is a crazy connection. That's pretty good. That's pretty good. Huh, okay. What do we do here? This is hard. Yeah, so this should just be like the generic engine function. I think we should just have like a separate function for each of these different things. Oh wait, this is wrong. It should be register node. Should be store node. Okay. I think what we do is we have a function for each of these, and then we can kind of just like use those to recurse in a way, I guess. Yeah, or maybe we could do like a stack of some sort. Or like a work list, maybe. It's hard work just like coding? Yeah, that makes sense. I guess if we're gonna recurse anyway, we should just recurse all the way. And just... I don't think we should worry about the recursion limit, right? Like, surely that's not a concern. At least for the size of tests that I'm writing here. I really hope that's not a concern. Okay. Okay, let's figure this out. So we should probably have different ones here. And the reason I'm not making a visitor for this is because like we're only testing for 3 cases here, so I'm not really concerned about that. Or register. And I think just making a visitor for this would just make this way more complex. Alright, we can make these like tri-tile. Or ASM node is a little bit trivial, we don't really care about that. We just care about these two. And since we're only dynamic casting 3 times, I don't really think I need to make a whole visitor for this. Dynamic cast is fine for like one-off conversions, whereas a visitor is better when you have to like do it across a class, I guess. That is like my threshold for determining which to use. Let's make this that. Do that. Oh, I forgot to write. Okay. This is not fun. Or I guess we can make this like tile recursive or recursive tile. Yeah. That sounds a little bit less awful to me, at least. Not that like it matters, to be completely clear. You know how people joke about like how papers are just like very verbose? This is like the equivalent of that for me. It sounds better, so I will use it. And if it turns out it's not better, then like, great, I guess. I guess if we're recursing a visitor, it would make sense anyway. Huh. We might have to make a visitor. Okay. Or no, actually no. Other children should be registers. The children should be registers, so this should not be a problem. Yeah, okay. Let's try this for now. What are the requirements to be hired in this field? I mean, there's not really like strict requirements. The biggest stuff is just like strong theoretical knowledge and like maybe some hands-on experience on like the main frameworks that like whichever job is, I guess, requiring. So like a C++ compiler dev would probably need to be familiar with like LLVM or like GCC's tooling, for instance. Whereas like someone that's like making I guess like a compiler for custom hardware would probably need like MLIR experience, for instance. It's not like very well defined, obviously. Like it varies from job to job, but there are like some broad trends, and I think I've kind of outlined those at least to the best of my ability. What type is this? It takes register node, store node. That should take the correct one. Yeah, okay. Okay. I don't like this design either, though. This seems quite awful. Maybe I should just like, we might just have to make a giant tree though, because I don't want to like repeatedly, I don't want to like repeatedly dynamic cast. I want to just do one dynamic cast, or at least like cache it if at all possible. Okay, we might have to do like a backtracking-y sort of algorithm. Oh, I don't want to do this. I don't want to do this like that. Okay, well, we'll try it like this. I imagine I'll have to like re-architect this multiple times, but I'm just gonna mentally prepare myself for that and just deal with it. Yeah, okay. So let's start with register node. So you want to get the source real quick. Oh no, we need a visitor. Oh, we need a visitor. No, 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 no. Oh no, we need a visitor. Okay, all good. Let's just do a dynamic cast tree for now. I guess this will also illustrate why this is bad. Or I don't know. How do I even do this? This is hard. This is rather difficult. How am I supposed to tile this? Maybe I should like draw out tiles, I guess. That will be what I spend time doing, I guess. I will scribble on paint.net and draw tiles. Install and exit, sure. Okay. I guess we could start with just like the generic ones that we generate from trees, and then we can go from there. We can get more creative with it. Which language is that one you're typing in? This is written in C++. Yeah, C++ is like C++ is generally pretty important for compiler stuff. Yeah. Someone is showering. Yeah. It's all in C++ at least. There's not really anything else interesting to say here. Okay, so we have binary op. That's something we can tile at least real quick. So this is reg. So this should be op, and then this takes. Python is not replacing it, correct. Python is rather slow, actually. It's slow, it's not that great to maintain for the most part for these sorts of systems-y things. Register or immediate, by the way. That's what r/i stands for. Yeah, Python is not going to be particularly great at these sorts of things, at least. What is the call tree? Oh, this is not a tree that we need to worry about. Yeah, so binary op. Oh, we just have 4 cases to worry about for basic trees. The next one is an allocate, register. I don't know, this should probably not be. Huh. Yeah, maybe we shouldn't do an allocate like this, actually. That seems suspect to me. I'm gonna skip allocate for now. I might have to change that design choice later. Load shouldn't be that hard, though. So register, we have, like, load. This is just literally load instruction. And this takes putter, which should be r/i, I think. Or wait, no, that should be an address, right? Let's look at the cheat sheet again. I don't know, the load doesn't make sense. This should just be a move, right? Everything doing is important. Why are you saying it's not? I mean, like, it's all insignificant to some degree. But like, I'll take your word for it. I appreciate the support. Okay, this is what we would need to do. What is... Oh, I see. Okay, we're gonna need to do some interesting stuff here. This will have to be a move, I think. Yeah, so I guess we can do some things here. It should be r/I, I think. Huh, wait, no, this doesn't make sense, no. Okay, we might need like a memory address type actually. That might be what we need to do here. Yeah, we definitely need memory. There's like the effective address thing here. There's like 3 different memory addressing types. I think this is the one we care about for the most part. As well as this. But it's mostly this. What are we doing? Good question. I don't know what I'm doing. Jokes aside, so the overall project, I'm not sure how familiar you are with my streams, but I haven't seen it around, so I guess I'll give the whole spiel. I'm writing a compiler from C to x86-64. Right now I'm working on, I guess, building up to code generation. So I have, I've lowered the source language into an optimizer language. I've done optimizations on, I guess, that memory representation. So now I'm working on the part where I turn that into assembly, and then I can vomit out the assembly. Unfortunately, the optimizer language and assembly do not map one-to-one onto each other, so I need to do a lot of convoluted stuff to get to that point. And part of that involves a lot of like covering trees. So I need to like generate tiles to cover trees with. Metaprogramming to some degree, yes. I guess a lot of compiler stuff is kind of metaprogrammy as a whole. What's good, Skittle? It's good to see ya. Yeah, I guess we could... This should not be register immediate. This should just be mem. Some sort of memory. Or let's make this M, actually. Yeah, so we want... Let's just add a key for myself in the corner, because I will forget a lot of this stuff, I think, somehow. So that's M, I equals immediate. R is register. I want to join this field. Are you asking the skills that yeah, Emma, are you asking the skills that you need to be a compiler engineer, or are you like asking this like the stuff you need to know for like web development? I can't really tell what you're asking from the question. That might just be like a skill issue on my end. Languages needed like for web development? Oh, we need store. That's also what I'm missing. And then this is a memory address. I'm gonna assume you're asking about web development. I guess like if you've like heard of like the like MEAN-stack or like MERN, I think like you can kind of think of grouping technologies into like those sorts of 4 categories. And then like so like that's like the at least technology side what you should be familiar with. So like some sort of database technology, whether it's like MySQL or Postgres or like Mongo. There was another one that I don't remember off the top of my head. It was pretty trendy, at least. I don't remember. So that's like the databases. Web frameworks, you want to kind of just like pick one. Either like React or Angular, or like one of the newer ones like Svelte or something. I believe all of those are built on top of JavaScript or TypeScript, so you probably want to be comfortable with both of those. The good thing about TypeScript is that like it's kind of just like JavaScript but with types, so I think it's worth learning TypeScript at least, and you will pick up JavaScript on the way. So that's the first two letters, or no, that's the first and the third letter. The second letter is E. That's Express. That's another technology for like deployment, I think, if I remember correctly. And then I guess same goes with the N, which is Node. I could be wrong about those two. You'd have to double check, but those are like pretty common terms that I hear. I haven't like looked into it enough. But yeah, language-wise, I think you should at minimum be comfortable with JavaScript and TypeScript. You should also probably be comfortable with like writing SQL queries. And then on top of that, you should understand technology, like various different database technologies, various different web frameworks, or even just like pick one web framework and go with that. And it'd probably also be helpful to get used to like cloud technologies. So things like AWS or like Microsoft Azure or like Google Cloud. Just like pick one of the three. All of the concepts kind of carry over to one another. I think like if you know enough about them to understand if you know enough about them to like have the phrase serverless server make sense to you, I think you will be in a good spot. It sounds insane at first. Like, trust me, that it does sound like completely nonsense, but it will make sense. You just need to get to that point. Yeah, I think that's like kind of the pile I know of, at least. It's not really in the direction of where I want to move my career, so I haven't like thought about it more than that, at least. Is AWS in demand? Very much, yes. I think the fact that like so much of the internet went down like a couple weeks ago when AWS had an outage, the fact that like all of that went down, I think shows that AWS is pretty important to know. Think of it as like the platform that you'll be deploying your code on. I guess that's where Express falls into that, right? But yeah. I think that'll be very valuable. I think there's like certifications for it, right? Yeah, there's like certifications for AWS. I know Azure has an equivalent. That might be good to pick up as well. That might be like a good part to throw in there. But yeah. If you have more questions about this, I'm not really sure how much I can help you because, again, I just don't do this stuff. So, yeah, that's kind of like the extent to which I can help. So, yeah. Greetings from Chile. Welcome. Good to see you. It's crazy to think that a lot of people watch me from across the world. You can interpret that sentence however you want. Good luck. Thank you. Okay, so these are like the 3 trees we want to worry about tiling for now. I'm not sure what to do with the allocate, because we're gonna need to like pre-allocate that in some way. I think we might just like put that in like preamble. We might make that like a virtual move something. Number of possible web stacks you could use in Stain. Yeah, there's like, you can kind of just like do a linear combination of them, I think. Just like any sort of combination. You have like all of the permutations of, I guess, everything in each category, at least. Okay, so what will this translate to? This should be, I guess, like, okay, what do I do here? So I guess we want to move. Okay, so this output should be stored in this register. So we should just move. I guess we could do like let's give things labels so I don't get confused. Let's do A, let's do B, and let's do C here. This should be A, should be B, should be... This is not a register, what am I doing? This is wrong. From Rocco and got this recommended? That's crazy actually, yeah. I feel like it's always really cool just hearing about where people come from in the world. Because I know like a lot of people have different educations from me. So at least in my opinion, I feel like just like learning about what different people do and like how they were, I guess like their sort of life experience is just like always been quite interesting to me. Because like it's really crazy to think just like even if you're just like walking down a street and like you see a bunch of people around you and like it's really crazy to think every person has like their own life experience as well that is completely distinct from yours. And it's just like, wow. So I'm gonna move. Okay, let's add more labels here. I forgot to add 2 more labels. So this is A and then B. Yeah, okay, this makes sense. So we want to move A to C. And then we want to do whatever the op is. Oh boy, I can't handwrite. There we go. So then this we want to... This is source destination, right? So what direction does subtraction happen? Subtract source from destination. So then this should be BC, I think. Yeah. B to C. So we're applying B onto C is the way I'm thinking about this. Okay. Next is this. So this is a load. So we want to move to B. So we want move. Oh, mop, move. Okay, so we want to move. Let's. So we want to, I guess this is, how do we want to represent the memory op here? So it should be like, this should just be, oh, it's just literally the thing, so. So we can do like $sign or %, I think. So this should be, let's do a bit of patchwork real quick. Should be 5 real quick. How much time did it take you to learn C++? I technically learned it my freshman year of college and I'm a senior now, so I think that's like 3 years. But that's like a very technical reading of it. In terms of how long it took me to like, I guess go from, or learn C++ in terms of like writing meaningful code, I think the only like real program in C++ I've written is actually just like this compiler project right here. And I started writing this in like July, I think, so. Make of that information what you will. It's definitely very doable to learn if that's something you're interested in. I guess we can do like $sign % maybe. Alright, let's do it the other way. So the $sign is the %. Yeah, so we need that. So we want to load from memory. So we want to move from A to C, or A to B rather. And B is a register. So this is reg B. Oh man, it feels like I'm relearning assembly for the first time. This feels very fresh. I'm quite happy with this experience actually. Let's move this over a little. Yeah, we'll deal with that. And yeah, patch the gaps. So this last one is the opposite direction, so we want to move from reg percent or percent $sign A to just whatever B is. B should just be a literal, I guess. Learn C++ fairly quickly with a tour and a lot of C++ talks. Ooh, yeah, all the talks are really good online. Like C++ Con, C++ on the C. They're all great to listen to. I find them really cool. Yeah, you will learn a lot from those. Just like passively even. Learned C++ and then unlearned it, and I'm learning it again. Yeah, that's kind of like exactly what happened to me. I thought I was gonna be a Python dev at one point, and then I realized I kind of suck at Python. And then I was like, ooh, these compiler things are pretty cool. So then I decided to learn about them. Okay, that's all the stuff we need to work with here. So, okay. What the hell do we do with this? Let's just dynamic cast as op or load, I think. Thought Python was a shit and then tried to write an actual piece of software and discovered I have no clue how my computer works. That is the exact experience I had as well. I did a lot of like Discord bot writing and none of it ever went well. And I was like, this is really slow. And then I was like, wait, I'm just writing really bad code. So yeah, I guess that's kind of a universal experience, unfortunately. I hate not having static types in Python. That's fair, yeah. It's not like the worst fate though, to be honest. Like, type annotations are generally good enough, to be honest. Okay, so given these tilings, what do I do here? Maybe I should define tile? Or what else could I do? I wonder if I could generate like bit strings for each tree. That could be an interesting approach I take here actually. I might do that. So like, yeah, this is probably like some really deranged shit actually. I'm not really sure if this is a good idea, but we'll find out very quickly if it is or not. So what I'm thinking about, let's say we have like some instruction tree. So this is like register. It's like reg A. So reg A equals like we want to add. Yeah, let's say this is like we want to add like reg B and then we want to add reg C. And then or we could do like, oh, wait, this is so exciting actually. I could do some really interesting stuff here. So then reg B is like times, or this is like another add for instance. And then this takes like 1, this takes like 1 for instance. This takes like plus, this takes 1, this takes like 1. So what I'm thinking we could do here is we could kind of just like, we could like serialize this tree. Do you remember that one LeetCode problem where it's like flatten a tree or something like that? Let me find this real quick. This is very relevant. 'Cause, 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 'cause Where's like serialize? Yeah, it's like this one, I think. Something like this. So like we serialize a tree into like some sort of a structure like this. And this is like a binary search tree, so that's not like completely applicable, but we can assume just like any generic tree. So my idea is we could serialize like this sort of a tree. Our, I guess, like instruction tree for any like instruction sequence, I guess. My idea is we can like serialize this in some way, and then we can use that serialized version to, I guess, like do like, yeah, we can look at the serialization of it to, I guess, determine information about how we can tile it instead of having to like dynamic cast it each time. So we could like keep like some sort of like bit representation, which it'll be very ugly, and I'm not sure this is gonna work, but in theory it would be quite great. Correct Python code looks ugly, so I never liked it. Yeah, that's something I've been like thinking about as well. Like historically Python has been like, I never thought there was a problem with it, but I feel like the more low-level code I write, the more offense I take to Python in general. It's just like, it just feels kind of sloppy, I guess. It's kind of how I'm thinking about it. What's good, Relics? Good to see ya. I've been using functional languages exclusively so long that I forgot how to write good imperative code. I feel ya. Our intro sequence is in like Racket, or like our first the first course in our intro sequence. So like a lot of people kind of just like, a lot of people hate it. Some people like it. I go back and forth. It's very easy to forget how to be human, I guess. How would I even serialize this in a meaningful way? Or I guess I could like keep fuck. I could keep like 2 arrays maybe. Or like 2 vectors. We could take like, this is so stupid. We could take 2 vectors of like putters. Or we could keep like a, oh, so it's like 1, 2, like 3, 4, 5, 6, and then like 7, 8, 9, 10, or something like this maybe. We can kind of like do a BFS sort of tree. Then what do we do there? It's my idea. So we could like make some sort of like a bit mapping. Depending on like what type of node this is. This is really dumb. Why am I doing it like this? We're like generating trees and then we're like flattening them again. We have like a control flow graph, and so we have like, oh my god. We have a tree representation of our program, then we flatten it down, then we do stuff to it, we re-tree it, then we flatten it again, then we turn it into a tree again, and then we flatten it. What am I doing with my life? Okay. I want to do something interesting here. I don't think there is a good way to do something there. I'm gonna need to think of a better algorithm. Maybe I could look at the existing books for this, maybe? I know the Cooper book has something about this. Yeah, this didn't talk about tree generation and like tree merging, but this definitely talks about tree tiling. So I can definitely look in here, I think. Thank goodness. Thank goodness there's something here. Let's go single page again. Yeah, so this is like the algorithm I'm trying to, or like this is the stage that I'm trying to implement. So tree pattern matching. Yeah, so we've now expressed it as trees. We've gotten that far. We don't need to worry about that anymore. Low-level AST is a detailed model. Similar trees represent operations. Yeah, okay. Apologies if this is a little small. Let me know if you want me to like zoom in on this. Yes, tilings exist. They need to cover everything, and then like they overlap nodes. Presence of a pair indicates. I see. Zoom. Okay, cool. All right. Hopefully this is a little better. Did you read the entire book? No. I've kind of just been like looking at books as like reference, at least. Let me know if this is still too small. I can't really do much beyond this, I think. Actually, this is like half a page, right? I can probably zoom in one more level. Yeah, okay. Adobe Acrobat. Lovely. Okay. Bottom-up rewrite systems. Something about that. Okay, I need to zoom out a little. Okay, so operands are subtrees or leaves. This is like the stuff that we figured out already. I'm not gonna spend too much time here. We kind of write our tree like this, actually. So that's pretty cool. Okay, rewrite rules. Yeah, so this is kind of what I'm like trying to do in this sort of diagram here. So we have like the three basic trees that we are like guaranteed to have 100%. And then those trees we can just like rewrite like this. Or rewrite into these groupings. Yeah, okay. So these are like all different types of operations. Rule 19. Ah, I see. Okay, yeah, there's a lot of stuff here. What the hell? Oh, I see. Okay, we're doing a lot of stuff here. Are those not just assembly operations? It's like sort of assembly, but like not really. The right side is like, I guess like what we're generating as an output of this is assembly with, oh yeah, so the right side is like the assembly generated. Except we haven't done like register allocation yet, so we still just have variables. We need to like figure a way to map out all of the variables into the fixed set of registers we have, which is a future problem. That might be like 1 or 2 months down the line, depending on how quickly or slowly I get through this. And then the stuff on the left is like our optimizer language. So the reason why this is important is it doesn't map one-to-one. So yeah, we need to account for that at least when we're doing this sort of stuff. Okay, and then we have cost estimates. What is the current task? This is all for instruction selection. So this is like the whole not one-to-one mapping thing I was just talking about. Yeah, so each rule has a cost. We want to minimize cost. That makes sense. This stuff I don't care about. This is just like making the rule set. Last time we were working on tree merging. Yes, all the tree merging stuff should be done. I might have to like change the way I generate one tree, but that's like kind of whatever. I'm not too concerned about that, at least. Okay, computing tilings. Okay, this is the stuff I care about. We need to... Yeah, so there's multiple ways to tile trees potentially. Here's a couple examples for like this tree. Yeah. They have different costs, which is interesting as well. So we want to pick the one with the lowest cost. There is a greedy way to do this, so that is the plan. What is happening here? All matches, that's what's being computed here. We can also just like order the tiles. We can order the tiles in I guess increasing cost order. And that will kind of skip a lot of the math here, I think. I thought you ran Arch. My laptop runs Arch. My PC is on Windows because I play Valorant, unfortunately. 0, 1, or 2 operands is correct. Yeah, it's a tragedy that I play Valorant. I could be so much happier if I didn't play Valorant. Yeah, okay, this actually makes a lot of sense. So then we have rules. What is tile? Oh, I see. Okay, that seems reasonable. Okay, I should read through this a little bit slower, I think. Let's take a low cost sequence. We will do this greedily because the optimal way is dynamic programming, and that is unfortunately slow. And I do not care enough. So we will do this. We'll do this at a reasonable pace. Okay, simple recursive algorithm. Is TN rule set instant nodes with 0, 1, or 2 operands. Okay, yeah. So you have these patterns. We can kind of treat it like that as well. Yeah. So we do need a visitor if we want to do that though. Tile. Okay, so that gets all the rules. That seems awful. So that computes all meshes. Oh, I see. Okay. Okay, that makes sense. The leaf, we can pre-compute it. That makes sense. So we want to recurse, and then we can match upwards. Oh, actually that makes sense, yeah. We don't have to go top down. We can kind of go bottom up, actually, I think. That might be smart. Yeah, I might have to do like a pre-order traversal or something. Or no, not pre-order. I guess post-order? Yeah, we could do like post order traversal. Or no, pre-order makes sense actually. We could do pre-order. And then we could break as well. Okay, a lot of this is not really helpful, to be honest, actually. At least I feel like it's not really helpful. Ah, I see. There we go. So how do we even look at this? What is happening here? Oh, right, we're assigning rules, I see. Okay. Yeah, I guess we could like keep a list of things, and then we could recurse on it like that. I don't really like this though. Yeah, okay. That's like the pile from that chapter. Okay. How much of this was helpful? Not a lot, to be honest. I feel like I don't know. I feel like I don't really like the way this book explains things, just personally, generally. Okay, I think I'll have to just think about this a little bit more off stream. Let me just like add braces here for myself to be, oh, that's awful. Yeah, let's just add braces. Oy. Okay. Yeah, I'm gonna post this screenshot in my Discord just so I like don't forget it. I do have to like study for exams, so is this at a point where I can like commit anything? I guess not really. I guess I can get rid of this. This should not be a store node though. I guess we can just keep this for now. What did I change in the header? Oh, I see. Humbled around a little. Okay. Yeah, I think I'm gonna call the stream here. It's time to study. Deep learning is quite scary, and I don't understand a lot of it. Yeah, I gotta figure out what the whole deal with transformers is. So that's what I will do now. Thank you all so much for tuning into today's stream. If you're new here, make sure you sub to the channel. Make sure y'all like the stream. It helps out a lot with the algorithm. Is there GitHub for this? If you're talking about this project, yes, it's called Panic. It should be pinned on my GitHub profile. Yeah, my GitHub is in the description along with my LinkedIn. So if you want to stay up to date with what I'm doing or check out any of the stuff I'm working on, feel free to look at my stuff there. Yeah, aside from that, also in the description is a link to my Discord. If you haven't already joined, you definitely should. Everyone is really chill. It's the best place to get notified when I go live. And yeah, I think that's about it. I don't think there's anything I missed there. I'm gonna go study now. Take care, y'all. Take it easy, and have a wonderful rest of your day wherever you are.